Hi, I'm Chris, and in this showcase we will shape some waves with the Weevil Stereo Graphic Waveshaper. I would consider myself a distortion aficionado, a connoisseur of delightful destruction, an admirer of audio mangling. Well, you get the point. I love distortion. Naturally, I have my fair share of way too many distortion plugins in my arsenal, and a tendency to abuse other effects for distortion as well. However, when it comes to creative distortion, I always gravitate towards waveshapers. With waveshapers, I'm able to form audio signals with surgical precision and utmost force. It's no wonder that I was very excited when I spotted the Weevil Graphic Waveshaper in the VM store. In my head, waveshaping and control voltage, it just made sense. And to this day, this particular model is irregular in my patches, but that's about to change. The DSP mastermind Weevil has once again blessed the VM ecosystem with an extraordinary waveshaping weapon, the Stereo Graphic Waveshaper. The Stereo Graphic Waveshaper is somewhere in between an addition to the Weevil Waveshapers and an upgrade to the Graphic Waveshaper. The user interface is overhauled, streamlined, and more in line with Weevil's recent releases. A powerful modulation matrix is now the central hub for CV modulation. And of course, the Stereo Graphic Waveshaper is now equipped with clever stereo processing. Now, before we explore the controls in detail, let's first clarify what a waveshaper does. It's pretty simple actually. A waveshaper maps the incoming amplitude of a signal to a given amplitude specified by this shape, the so-called transfer function. Think of this display as a graph. You have the x-axis, which is the incoming signal's amplitude, and the y-axis, which is the outgoing signal's amplitude. The shape, curve, or transfer function tells you which y value is equivalent to what x value. As follows, a straight line from the left bottom corner to the right top corner will map each x value to an equivalent y value. No distortion at all. If we mirror the line on the vertical axis, we have effectively inverted the waveform. And for instance, if we draw a line from the 0 point to the top at half of the x-axis, every y value is now double of every x value, and every x value above 2.5 volts is then clipped at 5 volts output. Therefore, an incoming signal of 2 volts is output as 4 volt, and a 3 volt input results in 5 volt output. And this applies to every signal you put through the waveshaper. We can conclude, waveshaping reshapes the signal based on its amplitude and a specified shape by mapping the incoming signal level to a new outgoing level. Now, how is this of any use? Well, oversimplified. That's how every type of distortion works. Distortion is a nonlinear process, so if we move away from the default straight line, we effectively apply distortion to the signal. In fact, we will explore many types of distortion that you can facilitate with this waveshaper later on in this video. First of all though, we need to familiarize us with the interface. We have already gotten to know the most important control of a waveshaper, the shape. The Weevil Stereo Graphic Waveshaper though has a lot more to offer. Besides the display, we can divide the interface up into the following sections: the signal and shape controls, the input and output section, the modulation matrix, the advanced options, and the node manipulation section. In the display we can intuitively move nodes by clicking on them and dragging them over the display. There are two types of nodes, however. The blue nodes are so-called line points and can be moved in X and Y direction, whereas the green hollow nodes, called control points, can only be moved in the Y direction. You can reset the position of each node by right-clicking it. The X value of the green nodes is always in the center between two adjacent blue nodes. And here's an awesome power user trick. Place your line points and then right-click the curve points to get straight lines between the line points. Generally, the blue nodes modify the line and the green nodes modify the curvature of a line. Speaking of lines, there are actually 3 visible lines in the display, a thin green line that connects all nodes, blue and green, linearly, a blue line that shows the transfer function as shaped by the nodes and shape controls to the left, and a white line that is the same as the blue line but following CV modulation. It's great to have all three lines visible, but remember, only the white line shows the actual transfer function at any given point in time that is applied to the signal. The last thing to note about the display is the grid in the background. It's divided into 1 volt steps for the X and Y axis, so it's quite simple to set exact values by aligning nodes with the grid. There is also a more precise way of interacting with the shape, the node manipulation section. When a node is selected in the display, we can use the X and Y knobs, only Y in case of a control point, to define its position. This is especially useful when you want to have exact values. Simply right-click and enter the desired value. Furthermore, the CV inputs below enable us to manipulate the shape using control voltages. Each input check has related X and Y attenuators. You can identify the corresponding knobs by the color coding. When you want to apply modulation to another point, simply select it by clicking on it in the display. The X and Y knob values are saved per point and can be edited again when you select the point again. On the bottom, there is a handy button that clears the X and Y knob values for every node, thus effectively erasing all applied modulation. The section to the left takes this Waveshaper from great to awesome. I like to think about this section as the signal controls and shape controls. Let's explore these knobs from top to bottom, starting with the signal knobs. Remember when I said this column of knobs is for the signal? Well, that wasn't really true, because the boost knob behaves somewhat like an input gain. But actually it rescales the graph. Same though. You can use this to literally boost the input amplitude by 400%. Now, since a Waveshaper works on the amplitude of a signal, this control can be used to amplify weak signals or increase the overall amount of distortion. The range knob adjusts the range of the graph. At 0, the maximum X and Y values are at 5 volt. By raising the range, we can linearly push the X and Y max values up to 10 volts. Adjusting the range enables us to draw waveshaping curves for signals up to 10 volts. Moreover, we can map values of up to 10 volts to the lower X values up to 5 volts to make the effect more striking. By increasing the range, the threshold of treating overshoots is also increased. So keep in mind that the output signal will have an amplitude of up to 10 volts when increasing the range. So it's best to introduce an attenuator, amplifier, or even another clipping distortion afterwards to lower the signal back to a sane range. The Waveshaper in its current state applies the same displayed shape to the positive and negative side of the input waveform individually. We will discuss how to change this behavior shortly, but for now it's important to understand that the effect always applies to the positive and negative portion of a waveform. We can use this to our advantage with the offset knob. It applies a positive or negative DC bias to the input signal, pushing it more towards the positive side when turning the knob clockwise, or more to the negative side when turning the knob counterclockwise. The feedback knob controls the amount of signal that is taken before the shaper and fed back into the input signal path, right after the boost and offset stages. This signal is combined with the input, and this cycle repeats indefinitely. The feedback knob acts as an attenuator in this case. However, you never need to worry about out-of-control feedback loops, as the clipper folder stage is inside of the loop, keeping the level under control before it finally goes through the shaper. Now, the Stereo Graphic Waveshaper takes this concept and expands upon it with additional feedback modes or routings. Things get interesting when the feedback junction is put after the shaper, so the signal goes through the shaper before being fed back. With intricate shapes, this can turn into noise pretty quickly, and therefore a filter is put into the loop. To enable these alternate feedback modes, you have to click on the Effects knob label and select one of the feedback modes. The mode dictates which filter is put in. You have the choice between a taming low pass and a tasty band pass. The filter frequency is set with the Effects knob. Additionally, there are crossfeed feedback modes that are absolutely insane. By selecting these modes, the two signal lanes, left and right signal are cross-fed into each other alongside the regular feedback. The amount of cross-feedback is dialed in with the width knob in the input-output section. Again, since the clip or folder stage is inside of the feedback loop, things can get nasty, but never out of control. This allows for some creative, destructive and highly corrosive sound design. Me personally, I love zooming into specific frequencies with the bandpass feedback cross mode, and then feeding the same input signal into both lanes, but choosing different frequency peaks to accentuate. Keep in mind that the whole architecture is laid out as a dual lane or stereo waveshaper, so each lane can have different settings and therefore can contribute different characteristics to the feedback circuit. The possibilities are endless, as there are vast soundscapes to explore in the cross-feed feedback circuit alone. And then there's the padding knob, which applies a logarithmic function to the input signal that is effective above 5 volts to smooth out clipping and folding behavior. This does also scale down the signal going into the waveshaper in order to accommodate for the onset of the logarithmic shaping. Padding can tame a very hot input signal and give a more rounded edge to the overshoots. Off to the right section that affects the graph. The shape knob at the top is like an attenuator for the shape itself. If you turn it down, the shape approaches a linear function, nullifying the wave shaping. You can still use all of the other shape controls and features, including the clipper and folder. In addition, this knob can be seen as a dry-wet control for the wave shaping effect. The control knob adjusts the effect of the curve points on the shape. At 100%, the shape follows the curve points. At 50%, the shape ignores the curve points. And at 0%, the shape moves away from the curve points. And then there's the edge knob that sets how the curve points interact with the curve, softening or sharpening the approach towards the line points. Symmetry adjusts the distribution of values on the x-axis. At the middle position, the x-axis is scaled linear. At 0, it becomes logarithmic, and at 1, it's exponential. This also works if the shape is 0 or if the shape is linear. I love modulating this control at audio rate to create some interesting wave shapes. The final knob is the shape effect knob. By clicking on the label, you get the drop-down menu to select an effect to apply to the shape. None, as the name suggests, does nothing. Wow! Vertical focus adjusts the width of the curve from the center, which stretches or squishes the transformation. Note that the center changes when switching from unipolar to bipolar mode. Vertical compression attenuates or boosts and clips the signal before the shape is applied. In unipolar mode, the signal is clipped at both the maximum and minimum values. In bipolar mode, this effect behaves more like a boost plus offset. The resolution effect lowers the bit depth of the curve. This is similar to applying a bit reduction to the signal, but things change when you apply modulation to the curve. Transformation fold is defined as phase transformation of the shape transformation curve, with the overflow of the curve being folded back on itself. From my observation though, this means that the curve is offset up or down, and when it exceeds the displayed graph, it is folded back. Naturally, similar to wave folding, the behavior is different in unipolar and bipolar mode. The most obvious novelty in Stereo Graphic Waveshaper is the flexible modulation routing matrix at the bottom. There are 8 input checks with attenuators and selectable destinations. These allow you to route CV or even audio rate signals to modulate almost any parameter on the interface. To select a modulation target, click on the label and select it from the drop-down menu. Be aware that the available options change depending on which stereo mode and what shape effect is selected. Compared to the Graphic Waveshaper, the Stereo Graphic Waveshaper has lost one input-output pair, but has therefore gained stereo capabilities. This knob that is labeled width mixes the left and right signals together to create more or less stereo separation. At 50%, both signals are mixed into each other equally, resulting in a full mono signal at both outputs. When the knob is turned clockwise, the lanes are separated more, until at 100% the lanes have no effect on each other whatsoever. By lowering the values from the 50% mark onwards, the signals become more and more inverted, as the left channel is mixed more into the right channel, whereas the actual right signal is lowered, and the right channel is mixed into the left channel, whereas the actual left signal is lowered. At 0%, there is complete stereo separation again, but the lanes have been exchanged. The label above the knob can be clicked to select the stereo mode. Two modes are available: independent and offset. With independent selected, all knobs on the left side affect only the left lane, and all knobs on the right side only affect the right lane. For instance, you can give both lanes individual offsets and symmetries to widen the output. In offset stereo mode, the right knobs act as an offset to the left knob values for the right lane. When applying modulation via the mod matrix to a target in offset mode, both lanes are affected. You can modulate the offset separately though. However, when in independent mode, the lane's controls can be targeted individually. Another important aspect of the width knob is its effect on the advanced feedback modes. In this case, the width knob determines the signal that is fed into the other chain. Next to the width knob are the CV envelope inputs. By patching a gate or envelope signal into a lane's CV envelope input, the modulation applied to the parameters of a lane are attenuated by this input. Thus, the modulation applied is limited by the level fed into this input. That comes in handy especially when modulating the offset, for instance. The CV envelope prevents the Waveshaper from outputting any signal created by the modulation itself. Of course, this effect can also be used to create interesting gated patterns or to apply a trigger decay to the modulation strength. What's left of this section are the input and output checks. There are two of each because the Stereo Graphic Waveshaper has two separate lanes, which can be used for a stereo signal or two mono signals. When only the left input is patched, it is replicated internally to the other lane and can then be treated by this lane and output at the corresponding output. And that's a great method to widen a mono signal to stereo. The same principle applies to the CV envelope input. The left signal is used for both lanes if the right check is not patched. Above the display there are a few menu buttons that either add to features or are used to configure the behavior of the Waveshaper. I think of these buttons as kind of advanced options, because you can do a lot with this module without ever touching any of these buttons. However, they are here for a good reason. So first of all, we have init shape, which not only initializes the shape to a linear function, but is also used to select the number of line points. Remember, there is always one more curve point than there are line points. We can select up to 7 line points, which allows for some very complex shapes. Right below the init shape button is the randomize shape button. If you ever need inspiration, just hit this button and it will randomize the x and y values of each curve and line point to create a new shape. I like to set up an initial shape and then hit randomize until it sounds like something good. I then have the option to fine-tune the shape manually. Next to the init shape button, we have the overflow button. Here we can select how a signal is treated that exceeds the set range. In clip mode, the signal is hard clip at max value. In fold mode, the signal is folded back onto itself when it exceeds the max value. In fact, by using the boost knob and one of these modes, you can set up a quick hard clipper or wave folder without ever touching the curve. The strength of the overflow protection is influenced by the padding knob. With padding, you can turn the aforementioned hard clipper into a neat little soft clipper. Moreover, the selected mode has a huge impact on feedback circuits, as the overflow protection is within the feedback loop, regardless of selected feedback mode. It's also important to note that the overshooting signal peaks are dealt with before the actual shaper, and that there is no further overshoot handling after the shaper. Usually this does not matter. But if you draw a very steep shape near the top or bottom of the shape and turn up the edge knob, the shape can actually go above or below the intended range. The next button is the gate button. You can select whether a noise gate is applied to the output or not. When gate is enabled, the output is muted when there is no signal at the input. You can set the Waveshaper to either unipolar or bipolar mode with this button. In unipolar mode, the current shape is applied to the positive and negative side of the waveform equally. In bipolar mode, you're able to manipulate both sides of the waveform with only one curve. In theory, this is a quick switch between symmetrical and asymmetrical distortion. And as if you haven't had enough distortion already, you can reapply the shape multiple times according to the fractal setting. The first few options simply apply the same shape for the given number. The options with an I added apply the shape inverted every other iteration. The CV resolution button sets how often the CV inputs are sampled. If you do not use audio rate signals for any of the CV inputs, you can save on resources by switching to Control CV. As a result, the CV signals are sampled only every 48 samples, thus a tenth of the actual sample rate. This is more than sufficient for envelopes and LFOs. However, if you plan on using audio rate signals to control any of the controls, and I highly encourage you to do so, you should switch to Audio CV. In effect, this will have every connected CV input sampled every sample, thus at full sample rate. You can still save on precious CPU cycles by using the Mix CV mode. This will use Control CV sampling for the parameters shape and control, and Audio CV sampling for all other modulation targets. Last, but definitely not least, there is the oversampling menu. Non-linear processors are prone to aliasing, which can clutter your signal and introduce unpleasant inharmonic frequencies. This can be the case especially if you use a complex shape with lots of sharp edges and/or drive a very hot and/or complex signal into the clipper folder. You should then use one of the higher oversampling options. The higher the number, the better, but also the more demanding on your CPU. When using audio rate modulation or high feedback, it is also advisable to use a higher oversampling option. In addition, you can use this effect adversely and downgrade the sample rate to intentionally introduce aliasing artifacts into the signal for some lo-fi crunch. It all depends on your intention. As mentioned in the beginning, all types of distortion can essentially be boiled down to a transfer function. Some distortion effects may apply equalization or dynamics manipulation before or after the transfer function, but that's basically it. Oversimplified, of course. Naturally, the Stereo Graphic Waveshaper is capable of producing various types of distortion. But before we get into all sorts of shapes, let's take a few seconds to analyze existing distortion modules. The easiest way to analyze what a distortion module is doing is to run a ramp-up signal through it and visualize the output. When you remember the Waveshaper display, it's easy to see that the ramp-up is perfect for scanning over X values and get the corresponding Y values. Here we have the excellent multimode distortion module Trishaper by Weevil. This module packs an abundance of algorithms to shape your signal. For now, we are particularly interested in its saturation function. I have set the algorithm to hyperbole, and we can see in the scope what the transfer function looks like. The same applies to the cube algorithm, and so on. There is actually another way to visualize the transfer function of a nonlinear model. We can use the Weevil Stereo visualizer to reverse engineer any curve applied to any signal. So let's take a sine wave and put it through Trishaper again. We patch the raw input signal into the X input and the shaped signal into the Y input of Stereo, and lo and behold, a plot of the applied shape. We can refine this graph by turning up the resolution and turning down the blur effect. The most basic form of distortion is a hard clipper. In theory, hard clipping occurs when an audio processor is overdriven to the point where it cannot handle the incoming amplitude, and thus clips the overshooting audio to its maximum value. We can achieve this behavior by drawing a line from the 0 point to anywhere at the top. Hard clipping usually only occurs in the digital world, for example when overdriving analog to digital converters. In the analog world, the clipping behavior is rather soft. This can be emulated by softening the approach to the bend. With clipping, we shape the maximum value. With crossover distortion, we shape the minimum level around the 0 point. When we lower the shape around this area, close to silent sounds are attenuated further. But when we increase the mapping in this area, those sounds are amplified. This can produce some very crunchy distorted sounds. Since the Stereo Graphic Waveshaper allows us to choose between unipolar and bipolar operation, we can create unipolar symmetrical distortion and bipolar asymmetrical distortion. Symmetrical distortion has only odd harmonics. This produces a woody, hollow sound. Think of square waves. In fact, with enough symmetrical distortion, anything can be turned into a square wave. Opposed to that is asymmetrical distortion, which produces both even and odd harmonics. This adds tube-like smoothness to the sound. Think about saw waves or triangle waves. These are different for the positive and negative part of the waveform, and we can mimic this by creating different shapes for each side in the display. The spectroscope verifies this. We can now see a lot more harmonics being produced. Be careful with this, however. Nonlinearity produces harmonics for each frequency that is present in the source signal. For a simple sine wave, this is only the fundamental, but for more complex signals, the spectrum can get cluttered quickly. More harmonics, more density. A West Coast mainstay to create complex timbres, the wavefolder. Naturally, this unruly type of distortion can be summoned with the Stereo Graphic Waveshaper in various forms. Wavefolding produces a lot of overtones from simple input signals. Therefore, it is often described as the opposite to filtering. Truly in the spirit of West Coast synthesis, building complex timbres from the ground up. In this example, we can see a makeshift wavefolder that warps the signal back and forth. This isn't really wavefolding, but produces similar results. We can produce more accurate wavefolding with the fold overshoot mode. In combination with a healthy dose of boost, the input signal is folded onto itself, is folded onto itself, is folded. Yeah, complex, isn't it? A cool feature of the Stereo Graphic Waveshaper is how it handles this folding in uni and bi mode. In unipolar mode, the signal is folded at the maximum and the zero line. Whereas in bipolar mode, the wave is folded at the positive and negative maximum. The latter resembles wavefolding in its truest form, but the former creates some unique timbres. There's one more trick we can use to shape the folding further: the padding. Turning up padding smooths out the folds and tames the madness, a little bit at least. By simply forcing all negative values to zero, the Stereo Graphic Waveshaper acts as a half rectifier. Of course, we can turn this effect around, leaving the negative levels as is and forcing all positive values to zero. But there's a more interesting thing to do altogether: full rectification. By inverting the negative or positive part of the graph, the corresponding values are inverted, resulting in a full rectifier. Apart from a typical rectifier though, the Stereo Graphic Waveshaper offers all of the in-between values as well. What about a full quarter rectifier? Or a offset skewed full rectifier? While all of the previous forms of distortion have an analog counterpart, more or less, there are also purely digital degradation facilities: bit and sample rate reduction. By forming a staircase curve, we can mimic the reduction in possible amplitude values that bit reduction does. Well, we can't really draw an accurate staircase due to the limitations of the line and curve point architecture, but we can get close. This does not mean that the Stereo Graphic Waveshaper is incapable of reducing bits, because it can do exactly that. With the shape effect resolution, the resolution of the shape is reduced, so it practically becomes a bit reduction staircase. Sample rate reduction can be added by abusing the oversampling options and setting a divisor for the sample rate instead of a multiplicator. Vintage lo-fi crunch galore. Since you can drastically reshape any incoming audio, the Waveshaper can turn simple waveforms into timbre-rich, complex waveforms with ease. For creative exploration, press the shape randomization button until the output is to your liking. Bear in mind, the more complex the input is already, the even more complex the output will be. If you use a convoluted shape with lots of turns and twists, you might want to resort to sines and triangle as input source. But who am I to tell you what to do? When audio signals can be shaped and contorted into vastly different forms, it's not a big leap to apply this treatment to modulation signals as well. In fact, we can use the Stereo Graphic Waveshaper to remap one modulation signal into different forms for different tasks. Here in this example, RFM1 LFO is producing a simple ramp-up wave. We have 4 modulation targets, and currently all of them receive the same ramp-up wave. With a flick of this switch, the simple ramp-up wave is processed by these 2 Stereo Graphic Waveshapers to produce 4 different, but related, reshaped modulation curves. We make full use of the dual-lane stereo architecture, with the offsets for the right lane. Since all of the modulation was generated by the same input, they are all in sync and will never drift out of sync. Additionally, changing the input signal changes all 4 modulation signals simultaneously. There's an abundance of fun things to do with a Waveshaper. From drastically reshaping signals to more subtle saturation. There's a lot to explore. Here's a more advanced idea to get you started. Slicing and splicing signals. These 2 Stereo Graphic Waveshapers are set up to cut opposing sides of the waveform. With some clever node CV, we can make this effect full range. Watch this. How does this work? Simple. The straight horizontal line tells the Waveshaper to map all x values in this range to one and the same y value, effectively cutting off the signal below or above the line. In order to move the nodes in sync, we need to take a look at the mapping. The point at the border must move up and down. That means its y value must be manipulated. The same goes for the curved point next to it. The point in the middle must follow the initial line, which leaves the amplitudes intact. This is done by increasing both the x and y modulation by the same amount. What's left is the curve point in the linear part. Since it is already moved by the line point next to it, only half the modulation is necessary to keep it locked in place. Now if I use this DC source as modulation signal, the waveform is clipped. If we wanted to recombine this upper part with a lower part though, we need to take some more actions. You see, since the 0 line is also moved, the part of the waveform that is clipped is now a DC offset. Therefore, if we mix the signal with its opposing part, the DC offset will be added to this part. What we need to do is add the inverse of the DC offset back into the signal, and that's happening here. This knob moves both the upper and lower part, and its output is also inverted and mixed with the final signal. Now we're moving. Naturally, this can be controlled by CV. Or, of course, audio rate signals. Just make sure that the CV resolution setting is turned to audio CV. Another not so obvious patching idea you can try with the Stereo Graphic Waveshaper is to use it as a mixer, with benefits. The width knob allows you to go from only a signal of that lane, over mixing both lanes, to only a signal from the other lane on each output. It's a big crossfader, so to speak, but there's more. With only one input patched, the signal going into the left lane is also passed to the right lane. You need to put a patch cable in the right output to enable the lane though. When you turn the stereo mode to independent, this gives you 2 individual Waveshapers with all signal and shape options that are applied to the same signal. This way you can blend between 2 different shaping styles of the same curve seamlessly. It goes without saying that you can also use 2 different input signals. The Weevil Stereo Graphic Waveshaper is a complex yet easy to use module. It invites to endless journeys through shapes and forms, warm saturation and bold destruction. With its array of smart curve and signal modifiers, the thorough modulation capabilities and the new stereo architecture, there's a lot to explore. As always, have fun patching and see you around.